Assalamu alaikum dear students, you are watching Study with Sheraz, and in today's lecture we are going to start with the spectroscopy. Basically this is a very important content in the field of chemistry, and from now to onward we are going to upload a number of lectures on spectroscopy, so stay tuned with us. Basically this is an introductory lecture related to the spectroscopy. In this lecture we will talk about the spectroscopy and the difference between the spectroscopy and spectrometry, and some related terms that are used extensively in the spectroscopy. So first of all, we would look what is the spectroscopy. Basically spectroscopy is the study of interaction of electromagnetic radiations with the matter. So this is the most simple and basic definition which shows that how the spectroscopy works. Basically in this technique we radiate the substances or the molecules, mostly organic molecules, with electromagnetic radiations, and then we study the interaction, that may be absorption, that may be transmittance, that may be diffraction, anything else. So we study the interaction between the electromagnetic radiations and the matter. The second important point about the spectroscopy is that it's aimed at identification of the absorbing structural features within the molecules. So basic purpose of spectroscopy is to identify the structural features that are responsible for the interaction of electromagnetic radiations with molecules. Basically not all the parts of a molecule are interacting with the electromagnetic radiation. There are certain structural features that interact more with the electromagnetic radiations, and we are going to study or identify those structural features. In the context of structural features, that may be some kinds of the functional groups, that may be some kinds of the bonds, that may be some kinds of the resonance structures, or you can say anything else. So the third important point that differentiates the spectroscopy from the spectrometry is that it's qualitative in nature. You people know that there are two types of the analysis in analytical chemistry, that is the qualitative analysis and the quantitative analysis. If we talk about the qualitative analysis, as the word indicates, these are the types of analysis which are based or which are aimed at determining quality of the molecules, or you can say the identify the elements or the structure of the molecule. So basically spectroscopy is a qualitative method of analysis. If we talk about the examples, so UV visible spectroscopy, IR infrared spectroscopy, and nuclear magnetic resonance spectroscopy are the most important types of the spectroscopy that we will study in the upcoming lectures. Basically spectroscopy and spectrometry are the two terms that are very much related to each other, and they are often confused with each other and they are used interchangeably, but they are quite different in their purpose and in their concept. So if we talk about the spectrometry, so it is the measurement of intensity of electromagnetic radiations. EMR stands for the electromagnetic radiation absorbed as a function of the lambda, that's wavelength, is called nu. Nu stands for the frequency and nu bar is the wave number. So in spectrometry we measure the intensity of electromagnetic radiations that has been absorbed by the certain molecule at a certain wavelength, at a certain frequency, or at a certain wave number. Basically spectroscopy and spectrometry are not different in their instrumentation. Spectrometry is done after spectroscopy. You can say these are interrelated to each other, and spectroscopy is done first. The main procedure is spectroscopy, but by making certain changes in the instrumentation of the spectroscopy or the spectroscopic instrumentation, we modify this technique into measurement. So first we identify the wavelength, wave number or frequency, and then we introduce some changes in the instrumentation and start measuring the intensity of the radiation. If we talk about the aim or goal of the spectrometry. So it's aimed at measuring concentration of absorbing molecules. Basically, we measure the intensity of absorbed radiation, and from that intensity, we try to find out the concentration of the absorbing molecules, because the intensity is directly proportional to the concentration of the absorbing substances of the absorbing molecules. So as we are finding the concentration, so it's a quantitative method of analysis. As you people know that quantitative analysis are those analysis in which we find the quantity of the substance of the analyte. Mass spectrometry and atomic absorption spectrometry are the most important types of the spectrometric techniques. Here are some related terms that are used in the spectroscopy and spectrometry. The first one is the EMR, electromagnetic radiation. So it's the radiant form of energy, and it consists of the mutually perpendicular electric and magnetic fields. So basically, there are two types of the waves, that are electromagnetic waves and the mechanical waves. So electromagnetic waves are basically the radiant form of energy. It means that they carry energy in the form of the radiations, and it consists of the electric and magnetic field that are mutually perpendicular to each other, and these are medium independent type of wave. They can propagate through the space. Here next are given some characteristics of the electromagnetic radiation. And so first one is the wavelength. So distance between consecutive or adjacent crest or trough is called the wavelength. Basically, if we draw the electromagnetic wave, so this is the mean point. So part of the wave that is above the mean point is called crest, below is called trough, next again crest. So distance between two crests, this would be known as the wavelength. So this is basically the wavelength. So distance between two adjacent crests is known as the wavelength. That is represented by the lambda. If we talk about the units of wavelength, there are many units that are used in the spectroscopy. That may be meter, but meter is not often studied. Maybe mostly the studied units of the wavelength are micrometer. So 1 meter is equal to the 10 to the power 6 micrometer. That's equal to the 10 to the power 9 nanometer, and that's equal to the 10 to the power 10 angstrom. Basically, these two units are mostly used, but in IR spectroscopy we use the unit of the micrometer. So keep in mind the conversions of these units and the interchanging of these units. The next is the frequency. It's the number of waves of electromagnetic radiations passing through a point per unit time. Basically, frequency is represented by the nu, this symbol, and it's basically we fix a point on the path of electromagnetic radiation, and we count the number of waves that pass through that fixed point in a unit time. A unit time may be a second, it may be a minute, but mostly the second is used. So if we have fixed this point on the path of electromagnetic radiation, so we would count that how many waves are passing through this specific point in a unit time, and that would be known as the frequency. The unit of frequency is the hertz. Basically, hertz is called the cycle per second. So number of cycles passing through a point in unit time is called the hertz. The next one is the wave number, that is represented by the nu bar, and it's the number of waves per unit distance. You can say number of waves per unit length. So it's basically the number of waves that are passing through a unit length. You can say 1 meter, it may be 1 centimeter, it may be 1 micrometer, nanometer. So we fix a distance and then we measure how many waves are passing through unit distance, and that would be known as the wave number. And the unit of wave number is the per centimeter, because wave number is also defined as the reciprocal of the wavelength. So unit of wavelength if taken as the centimeter, so the unit of wave number would be per centimeter. And the last one is the energy. That's very important characteristic of the electromagnetic radiation. Basically, if we talk about the energy, so according to Planck's quantum theory, the energy of electromagnetic radiation is directly proportional to their frequency nu. So E is directly proportional to nu, and E is equal to h nu. H is basically the Planck's constant, its value is 6.626 into 10 to the power minus 34 joule second. Energy of electromagnetic radiation is dependent upon their frequency. Greater the frequency, greater would be the energy. So X-rays and gamma rays and UV is having the greater frequency, so it's having the greater energy. If we talk about the microwaves, radio waves that are having low frequency, so the energy content is also low. The unit of energy is joule or electron volt, and the very important is the conversion of electron volt and joule. Basically, 1 electron volt is equal to 1.60 into 10 to the power minus 19 joule. How this value is found out? We have a separate lecture on the electron volt, and the link is given in the description section. So most of the time we use the unit of electron volt instead of the joule. So this was all about the spectroscopy and the introduction of the spectroscopy and some related terms. If you have any question related to this video, you can post your question in the comment section. We will meet in the next video. Up till then, Allah Hafiz.